Now it's time to move on to adding fractions. And in order to do that, we need to revisit our formal definition of multiplication. One of our definitions was that multiplication changes units. And we need to do that, we need to use that when we add fractions, because to add, subtract, or compare values, they must have the same units. Instead of a period there, right, that is a key insight for all of mathematics. It's not something unique to fractions. It's not something unique to algebra. This is a fundamental truth. If we're going to compare which is more, we need to be comparing the same thing, right? So let's talk about that. Let's say we watch one movie, and that movie is pretty long. It's 120 minutes. It's 3 digits long. It's a big number. And then we watch another movie, and it is 3 hours long. That's only 3. That's a small number. Now, of course, you know 3 hours is actually more than 120 minutes because you convert between these two units all the time. Right? Let's see how we deal with that mathematically. If we take 120 minutes remember, multiplication changes units. I'm going to multiply that to change my units into hours. Now, this only makes sense if we first understand how fractions work, that if I want minutes to cancel, I need minutes in the numerator and the denominator. Well, minutes, hours. I want hours to remain as part of my answer, so that has to go up here. Right? Now here's the key insight. Multiplication changes units, but we don't want to change the value, we just want to change the units. We're not changing how long we're sitting in this movie, we're just changing what number represents that length of time by changing the units that we use to measure it. Right? So to change units, let's write this down here. To change units, multiply by 1. Technically, to change units without changing value, multiply by 1. Right? If all we're doing is changing the units, that's different from the examples I gave earlier about distance equals rate times time, or force equals mass times acceleration. There you're actually changing what it is you're measuring. But if we're just doing a conversion, we want to multiply by 1. Well, 60 minutes is equal to 1 hour. A number divided by itself is 1. 1 hour is equivalent to 60 minutes. These two values, these two amounts are equal to each other. So there we go. So I have 120 minutes divided by 60 minutes. Minutes cancels, 10 cancels, 6 cancels, 12 divided by 6 is 2, and I'm left with hours. Right? I'm using multiplication, 120 times 1/60th, to change my units. For the other movie, we're going to go the other way. 3 hours times, now I want the hours to cancel, and I want to be left with minutes. Well, it's not 60 hours in 1 minute, it's 60 minutes in 1 hour. Hours cancels. 3 divided by 1 is still just 3. 3 times 6 is 18, so 3 times 6 times 10 is 18 times 10. 18 tens we call 180. My units are now right? Whether I divide by 60 or multiply by 60 is determined by whether I'm converting from minutes to hours or from hours to minutes. Now this is the same exact way that we multiply for fractions. Let's say I want to add 4 plus 2/3. Well, 4 plus 2 is 6, but that doesn't mean anything. If I said 120 minutes plus another 3 hours, how long did I sit in my dark room watching these two movies? It's not 123 anything, right? If I want to add these two, I'm either adding 120 minutes to 180 minutes, 1, 2, 300 minutes, or I'm adding 3 hours to 2 hours, 3, 4, 5 hours, 5 hours, 300 minutes, same difference. But I'm not adding 3 to 120 or 2 to 180 because the units don't match. I can't just add 4 and 2. I need my units here to be the same as my units here. So how do we deal with that? We multiply by 1. What's 3 divided by 3? 1. So 4 times 3, there's 12. What are my units here? Thirds. This is 12 thirds, this is 2 thirds. Those units are the same. 12 thirds and 2 thirds, 12 and 2, that's 14 thirds. Now we don't usually write this step. I'm just emphasizing that we're factoring out the units the same way we do with minutes or x or anything else, right? 4 times 3 is 12, 2 is remaining 2, my units are now the same, so I have 14 of those. When we're adding fractions, there are actually 3 different scenarios we might find ourselves in. So we might have something like this. We might have something like this. Or we might have something like this. Now, we could just say, well, all of these we're adding fractions is the same kind of problem. But recognizing how these numbers relate to each other will guide our strategy for how to approach them. So let's look at our first example, 5/7 plus 2 thirds. Well, 7 and 3 are not the same number. Sevenths and thirds are not the same units. If I go by sevenths, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Okay, so there's sevenths. 1, 2, 3, 4, 5 of them gets me here. So from 5/7, I want to count by thirds. Well, this isn't a third. This isn't a third. How big is a third? Well, I'm going to have to look at this one. Maybe there. Maybe there. I'm just kind of eyeballing. Do those look like they're all the same distance? So I'm going to take this distance of 2 thirds and then add that on to my 5/7. Well, I'm off the page for one thing. But it's not lining up with any of these blue lines. It's not going to line up with anything because my units aren't the same. So what do? We get the same denominator. We multiply by 1. We multiply by 1. And I choose my number divided by itself, version of 1, strategically so that this unit becomes the same unit as this unit. 5 times 3 is 15. 2 times 7 is 14. 15 plus 14 can now be done because I have 21sts as my units. It's the same factoring that we did for combining like terms. Right? 15 21sts, 15 times this. 14 21sts, 14 times this. That 1 21st can be factored out. That's what we're doing here. Now, all of this writing is kind of unnecessary. We don't usually show these steps because it just makes the problem look like it's taking longer. But that's that underlying use of the properties of our operations that makes this possible. Right? Now we can add 15 plus 14, 10, 25, 26, 27, 28, 29, 21sts. And so we're done. Now, any number here that's a multiple of 7, 7 times some number, and that's also a multiple of 3, 3 times some number, could have worked. But why would I use 42 when 21 works? Why would I multiply by anything more here than is absolutely necessary? Right? That's making your numbers bigger than they need to be, and it's ensuring that you're going to have to reduce later. Now, in this scenario, multiplying by the other number is both the most obvious and the least amount of work for these particular numbers. But when I change the numbers a little bit, what was our second example? 5/6 plus 2/3. If I use that same strategy, times 3 over 3, times 6 over 6, I will get the same denominator. The strategy will always work. But that doesn't mean it's always the best strategy. 5 times 3, 6 times 2, 10, well, 18 is our denominator here, so I have 10, 20, 25, 26, 27. And notice 27 and 18 is not going to be our final answer. I can factor this. 27 is 9 times 3. 18 is 9 times 2. So we get 3/2. Now, for this example, I was trying to use small numbers to not overwhelm you from the beginning. 27 and 18 aren't so bad, right? Factoring those, I hope, wasn't too troublesome for you. But there's still an easier way. If we pay attention, we can see I don't have to do 6 times 3. I can leave the 6 alone because this 3 is a factor of 6. Or another way to say that, 6 is a multiple of 3. 5/6 can just sit there as 5/6. 2/3 is equivalent to 2 times 2 is 4. 3 times 2 is 6. I have the same denominator now. 5 plus 4. That's 9/6. I didn't bother to write the step. I should have 15 plus 12 all over 18. 5 plus 4 over 6. Now I still have to reduce. Sometimes the numbers just work out that way. But spotting 3 as a common factor is, I hope, easier than spotting 9 as a common factor. So when one denominator is already a multiple of the other, leave that one alone and just multiply by whatever that missing factor is over here. Now the third scenario, which we'll actually have to get to in another video because this one's starting to go kind of long, is when neither number is a multiple of the other, but there is still a shortcut. I don't have to do 6 times 9 and 9 times 6.